Hello, and welcome to Boring Science for Sleep, a quiet place where science becomes slow, soft, and easy to drift through. Tonight, we'll gently explore what lies beyond the Milky Way. Together, we'll leave our familiar galaxy behind, wander among neighboring galaxies, follow quiet rivers of stars, and drift toward the vast, silent reaches of the universe, simply noticing, never rushing. Before you settle in, if you enjoy these peaceful journeys through the wonders of science, you're welcome to like this video and subscribe, only if it feels right. And if you'd like, tell me in the comments where you're listening from and what time it is where you are. It's always a quiet joy to see listeners gathering beneath the same night sky. Now, dim the lights, settle into a comfortable place, and let your breathing become slow and easy. There is nowhere you need to be, nothing you need to solve, and nothing you need to remember. You are safe, you are warm, and for a little while, the universe can simply carry you, one quiet star at a time. You do not begin this journey by moving quickly. Instead, you begin by becoming still. There is something comforting about imagining yourself resting quietly on Earth, while everything else continues its patient motion around you. The room around you feels calm, your breathing grows slower, and somewhere beyond the ceiling, beyond the clouds, beyond the gentle blue sky that belongs to daytime, an unimaginably large universe waits without asking anything from you. There is no rush to reach it. It has been there for billions of years. It can certainly wait another peaceful evening. You might imagine yourself lying beside a calm shoreline at night. Gentle waves arrive without hurry, touching the sand before quietly slipping away again. The universe behaves in much the same way. It never seems hurried. It moves through rhythms that are so slow they almost disappear into silence. Tonight, you simply listen. You simply drift. You are safe here. Long before people built cities or crossed oceans, they looked upward into darkness and noticed a pale band stretching across the sky. It looked almost like a river made of soft white mist, flowing silently from one horizon to the other. Different cultures imagined different stories for it. Some saw spilled milk across the heavens. Others imagined a celestial road or a bridge connecting distant worlds. Today, astronomers call this glowing band the Milky Way. The name may sound scientific, but the experience is wonderfully simple. It is home. Everything you have ever known has existed inside this enormous gathering of stars. The Earth, the Moon, the gentle warmth of the sun, every mountain, every ocean, every forest, every person who has ever watched a sunrise or fallen asleep beneath a quiet sky, all of it belongs to this single galaxy. When you first hear the word galaxy, it may sound enormous, almost too large to imagine. Yet perhaps it becomes easier if you picture something much more familiar. Imagine standing on a quiet beach at night. Now imagine every grain of sand glowing softly. Each tiny grain becomes a star. Not every grain looks identical. Some shine a little brighter. Some appear smaller and softer. Together they create a peaceful shoreline stretching farther than your eyes can comfortably follow. A galaxy is something like that. Not a beach made of sand, but an island made of stars. Our own island happens to contain hundreds of billions of them. spread across distances so vast that ordinary numbers quickly lose their meaning. Rather than becoming lost in enormous figures, it is gentler to think about the feeling instead. The Milky Way is simply very, very spacious. Between many stars lies almost unimaginable emptiness, quiet enough that a single beam of light may travel for years before meeting another world. That emptiness is not frightening here. It is peaceful. It gives every star room to breathe, room to shine, room to become part of a much larger picture. If you could somehow rise gently above the galaxy, without any effort at all, you might notice its graceful shape. From above, it resembles a vast spiral. Its bright center glows softly, while long curved arms reach outward like slow streams flowing through darkness. Within those spiral arms, clouds of gas drift almost lazily. New stars quietly come into existence, and older stars continue journeys that have already lasted billions of years. Our own sun is not near the brilliant center, nor does it live at the very edge. Instead, it quietly circles the galaxy from a comfortable neighborhood, one among countless others. The sun has been following this gentle path for an incredibly long time. Completing just one journey around the Milky Way takes roughly 230 million years. That is such an immense stretch of time that it is easier to imagine it as countless generations of forests growing, mountains slowly changing shape, oceans rising and falling, and life quietly evolving while the galaxy continues its patient dance. Yet even that motion feels calm. Nothing races, nothing hurries. Everything simply follows the quiet rhythm shaped by gravity, the invisible architect that gently guides stars without making a sound. You might imagine gravity not as a force pulling sharply, but as an almost invisible current beneath a peaceful sea. A leaf floating on calm water does not know exactly why it drifts. It simply follows the current. In much the same way, stars drift through the galaxy, each following pathways that were shaped long before our own planet existed. As your imagination slowly rises higher, the Milky Way becomes easier to appreciate all at once. Its glowing arms curl through darkness. Dark clouds weave delicate shadows across bright rivers of stars. Tiny clusters sparkle like distant lanterns scattered through a quiet evening landscape. Somewhere within one of those countless lights is our own sun. Somewhere beside that single ordinary star is Earth. And somewhere upon that small blue world you are listening now. It is a comforting thought. You do not stand outside the universe looking in. You have always belonged inside it. The galaxy has quietly carried our little solar system through space for billions of years, never asking us to notice its steady journey. Tonight, perhaps for the first time in a long while, you simply notice that gentle motion. You notice how peaceful it feels to belong to something so vast. And as the familiar spiral slowly begins to fade into the surrounding darkness, another quiet thought naturally appears. If our beautiful Milky Way is only one island of stars, what other islands might be waiting beyond its distant shores? As the familiar spiral of the Milky Way slowly drifts behind you, the darkness ahead no longer feels empty. Instead, it begins to feel spacious. There is a quiet difference between those two ideas. Empty suggests something missing, Spacious suggests there is simply room for everything to breathe. The universe, as it turns out, is wonderfully spacious. For a little while, imagine yourself floating high above our own galaxy. The brilliant spiral that once seemed unimaginably large has become a gentle whirlpool of light beneath you. Its glowing arms stretch gracefully across the darkness. Yet from this peaceful distance, it is no longer the entire universe. It is simply home. Perhaps this feels a little like standing on a quiet hill overlooking the village where you grew up. From within the village, every street feels important. Every familiar path seems to define your world. But from the hillside, you begin to notice other villages scattered across the landscape, each with its own lights, its own quiet stories, and its own place beneath the same sky. Galaxies are much like those distant villages. Each one is busy with countless stars, planets, clouds of glowing gas, and mysteries waiting patiently through the ages. Yet from afar, they rest peacefully beside one another, separated by astonishing distances, but still belonging to the same larger neighborhood. Our own neighborhood is known as the local group. The name sounds surprisingly modest for something so enormous, and perhaps that is fitting. Astronomers often choose names that are wonderfully practical. The local group is simply the collection of galaxies that share this quiet corner of the universe with us. There are dozens of galaxies here. Most are small, some are little more than gentle gatherings of stars. Only a few grow large enough to become the great landmarks of our cosmic neighborhood. Among them, one shines brighter than all the others. Far ahead, another magnificent spiral slowly comes into view. Its light has been traveling for around 2.5 million years before finally reaching us. Long before the first humans painted cave walls, before the oldest forests you could imagine had taken root, those tiny particles of light had already begun their patient journey across space. Tonight, they finally arrive. This graceful spiral is the Andromeda Galaxy. If the Milky Way is our island of stars, then Andromeda is the neighboring island resting quietly across a vast, dark sea. At first glance, the two galaxies seem almost like distant twins. Both are elegant spirals. Both contain hundreds of billions of stars. Both gently rotate through the quiet darkness. Yet each has lived its own unique history, slowly growing through countless ages. If you could drift between them, you would not encounter crowded highways of stars. Instead, you would spend nearly the entire journey surrounded by silence. The space between galaxies is astonishingly empty, not frighteningly empty. Peacefully empty. It is a darkness so gentle that even light requires millions of years to cross it. The stars are simply too far apart to crowd one another. There is room for everything. There is room for stillness. Closer to home, two much smaller companions quietly circle the Milky Way. They are called the Large Magellanic Cloud and the Small Magellanic Cloud. Despite their names, they are not clouds like those floating above Earth after a summer rain. Instead, they are small galaxies in their own right. Long ago, sailors navigating the southern oceans noticed two soft patches of light hanging in the night sky. They appeared almost like tiny glowing clouds that never drifted with the wind. Only centuries later did people realize they were looking far beyond our own galaxy. These gentle companions continue to orbit the Milky Way, slowly dancing together through the darkness. Within them, new stars continue to form inside glowing clouds of gas, quietly adding fresh lights to an already beautiful sky. They are companions rather than visitors, members of the same cosmic family. Not every neighboring galaxy remains whole forever. Some become so closely tied to larger galaxies that they are slowly pulled apart over unimaginable stretches of time. One such companion is known as the Sagittarius dwarf galaxy. For billions of years, it has been quietly circling the Milky Way. With each slow orbit, gravity gently stretches it, drawing streams of stars across the sky like delicate ribbons dissolving into a larger river. Rather than imagining a violent collision, perhaps picture two streams joining together. The smaller stream does not disappear all at once. Instead, it gradually blends into the larger flow, until it becomes difficult to tell where one ended and the other began. Astronomers believe that remnants of this little galaxy are still scattered throughout the Milky Way today, becoming part of the home we have always known without us ever noticing. Another tiny companion, called the Canis Major dwarf galaxy, may also have contributed stars to our own galaxy over immense periods of time. Although astronomers continue to study its exact story, it reminds us that galaxies are not frozen objects. They grow, they change, they welcome new stars. Even something as enormous as the Milky Way has spent billions of years quietly gathering pieces of its surroundings, like a tree whose roots slowly reach farther through the soil with every passing season. Seen from this peaceful distance, galaxies no longer appear isolated. They resemble families. Large galaxies gently accompanied by smaller ones, bright spirals surrounded by tiny companions, each moving patiently under the same invisible guidance of gravity. Nothing seems hurried, nothing seems chaotic. Even events that require billions of years unfold with extraordinary calm. As you continue drifting farther away, the Milky Way and Andromeda begin to share the same quiet view, two luminous spirals floating together in an immense sea of darkness. Neither dominates the universe, neither stands alone. Together, they are only the beginning of something much larger than either could ever reveal by itself. And somewhere beyond these familiar neighbors, still farther than your imagination has wandered before, entire gatherings of galaxies quietly wait, stretching across distances so vast that our little family will soon become only one small thread in an even greater cosmic tapestry. The Milky Way and Andromeda now drift together behind you, their graceful spirals glowing like two quiet lanterns suspended in an endless sea of darkness. From here, they appear close, friendly, almost inseparable. Yet the farther you travel, the more your perspective begins to change. What once seemed enormous gradually becomes familiar. What once felt distant slowly becomes close. Perhaps you have experienced something similar while looking down from an airplane. Roads that once felt long become delicate threads. Entire neighborhoods shrink into tiny collections of rooftops. The world itself has not changed. Only your point of view has. The universe has a wonderful way of doing the same thing. As your journey continues, you begin to notice that our little gathering of galaxies is not alone. The local group, despite its impressive name, is actually rather small. It contains only a few large galaxies, along with dozens of much smaller companions quietly circling them. Together, they have spent billions of years moving through space, gently guided by gravity, almost like dancers who have learned each other's steps over an unimaginably long performance. From within the local group, it is easy to imagine that this is a complete community, but it is not. It is only one neighborhood among many. Far ahead, another gathering slowly begins to appear. At first, it is little more than a faint concentration of distant light. Then, as your imagination drifts closer, individual galaxies begin to emerge. Not one, not 10, but hundreds. This remarkable gathering is known as the Virgo cluster. Calling it a cluster may sound simple, yet the reality is quietly breathtaking. Imagine standing on a hillside at night, looking across countless towns spread throughout a peaceful valley. Each town glows softly with its own lights, yet together they create an even larger landscape of gentle illumination. The Virgo cluster is something like that, except every tiny point of light you notice is not a single star. Each one is an entire galaxy. Each galaxy contains countless stars. Each star may have its own family of planets, quietly circling around it. The scale becomes almost impossible to hold in your mind. So perhaps it is kinder not to try. Instead, simply picture an enormous valley filled with glowing islands, each peacefully shining in the darkness. That feeling is enough. Gravity is the quiet reason these galaxies remain together. It never shouts, it never pushes, it simply whispers across unimaginable distances, patiently encouraging galaxies to move together over billions of years. Unlike the gravity you feel every day on Earth, this cosmic guidance works with extraordinary patience. Nothing happens suddenly. Galaxies drift. They slowly change direction. Sometimes they pass one another peacefully. Sometimes they eventually meet. Sometimes they gently merge into something even larger. The universe has plenty of time. If you watched the Virgo cluster for only a single human lifetime, it would appear almost perfectly still. Even after thousands of years, you would notice almost no change at all. Yet over hundreds of millions of years, and then billions, every galaxy continues its quiet dance. Their movements resemble leaves floating across an almost motionless lake, so slow that they appear still, yet always moving. Among these countless galaxies are many different shapes. Some resemble elegant spirals, much like our own Milky Way. Others glow as smooth, rounded collections of older stars, almost like softly illuminated pearls drifting through darkness. Some have unusual forms that seem slightly stretched or gently distorted, carrying the memory of ancient encounters with neighboring galaxies. Astronomers have carefully named these different families over the years. But tonight, those names matter less than the feeling they create. Every galaxy tells a story, not with words, but with light. One galaxy may still be quietly creating new stars inside cool clouds of gas. Another may have spent billions of years growing calmer, its brightest days already far behind it. Some are surrounded by graceful companions. Others travel almost alone, Each has lived its own long history beneath the same silent universe. As you continue drifting outward, another realization gently appears. The Virgo cluster itself is not the final destination. Just as villages become towns, and towns become cities, galaxy clusters also belong to something even larger. Long ago, astronomers began noticing that many clusters seem connected across astonishing distances, forming enormous regions where galaxies are slightly more common than elsewhere. For many years, these immense collections were called superclusters. Our own local group and the Virgo cluster both belong to one of these vast regions. You might imagine standing on a mountain and looking across an entire country at night. Individual cities are scattered everywhere, each glowing softly beneath the darkness, connected not by visible lines, but by their shared place within a much larger landscape. The galaxies of our neighborhood belong to such a landscape, not because invisible walls hold them together, but because they formed within the same broad region of the young universe, slowly shaping one another through gravity across unimaginable ages. Even this description remains wonderfully incomplete. The more carefully astronomers observed the universe, the more they discovered that these enormous regions are themselves connected by delicate structures stretching across the cosmos. We will discover those quiet pathways soon enough. For now, it is enough simply to notice that the universe enjoys gathering things together. Stars gather into galaxies. Galaxies gather into groups. Groups gather into clusters. Clusters become part of something even larger. Again and again, the same gentle pattern quietly repeats itself. There is something deeply comforting about that repetition. Nature does not rush to invent entirely new ideas. Instead, it patiently builds larger expressions from familiar ones, almost like waves becoming tides, or small streams slowly joining together until they become broad rivers. The farther you travel, the more peaceful this pattern becomes. Nothing feels random. Nothing feels lonely. Every galaxy belongs somewhere. Every cluster has neighbors. Every quiet island of light is part of an even greater landscape waiting patiently beyond the darkness. And as the countless galaxies of the Virgo cluster slowly fade into a broader view, you begin to notice faint threads stretching between these immense gatherings, so delicate that they almost disappear into the blackness, quietly suggesting that the universe itself may be woven together far more beautifully than anyone once imagined. The farther you drift from the familiar galaxies of our neighborhood, the quieter everything becomes. The brilliant spirals that once seemed so immense have softened into tiny islands of light. The great Virgo cluster has become only one glowing region among many others. Darkness fills most of your view, not an empty darkness, a patient one, a darkness that has never hurried to explain itself. For a long moment, it almost seems as though the galaxies have been scattered carelessly across the universe, like handfuls of glowing sand tossed into an endless night. But the universe is gentler than that. If you remain still, if you allow your eyes to slowly adjust, another pattern begins to emerge. At first, it is almost impossible to notice. It is so delicate that you might wonder whether you are imagining it. Soft lines, gentle threads, faint bridges connecting distant gatherings of galaxies. Little by little, the picture becomes clearer. The universe is woven together. Imagine walking through a quiet meadow just before sunrise. The air is cool, everything is still. Across the grass stretches an enormous spider's web, so delicate that it almost disappears. Only when the first light touches the tiny drops of morning dew do the silk threads begin to reveal themselves. The web was always there. You simply could not see it. The universe is much the same. For countless generations, people could only observe individual galaxies, one by one, bright islands floating in darkness. But as telescopes became more powerful and astronomers patiently mapped larger and larger regions of the sky, an extraordinary picture slowly appeared. Galaxies were not randomly scattered. They gathered along enormous invisible pathways. Today, scientists often call this breathtaking arrangement the cosmic web. It is one of the largest patterns we have ever discovered. Not because someone designed it, not because anyone built it, but because gravity has been quietly shaping the universe since its earliest moments. Imagine rivers flowing across an immense landscape. Water naturally follows gentle valleys. Over time, small streams join together. Those streams become larger rivers. The rivers eventually connect entire regions. Now replace the flowing water with galaxies. Instead of liquid, imagine countless islands of stars, slowly gathering along invisible currents that have existed for billions of years. That image comes surprisingly close to what astronomers observe. Along these vast cosmic threads, galaxies are more common. Clusters of galaxies form where several of these enormous pathways meet, much like busy crossroads where many rivers eventually come together. Between those glowing threads lie places that are remarkably quiet. These immense regions are called cosmic voids. The word void may sound lonely, yet perhaps it is kinder to think of them as peaceful valleys between mountain ranges. They are not perfectly empty. A few galaxies still wander there. Tiny clouds of gas quietly drift through them. Even faint particles continue their patient journeys. But compared with the bustling rivers of galaxies nearby, these regions feel wonderfully calm. Imagine sailing across an ocean where distant islands gradually disappear behind the horizon. For hours, perhaps even days, nothing interrupts the gentle rhythm of the water. Then, slowly, another chain of islands begins to appear. The cosmic voids are something like those long stretches of peaceful sea. Not lifeless, simply spacious, very spacious. One of the greatest mysteries hidden within this beautiful structure cannot actually be seen. Astronomers believe that most of the gentle framework holding the cosmic web together is made from something invisible. They call it dark matter. Despite its mysterious name, dark matter is not thought to be dark like black paint, or dark like the night sky. It is simply something that does not shine. It does not glow. It does not reflect light into our eyes. Yet its quiet gravity gently shapes the universe around it. Perhaps the easiest way to imagine it is to think about the roots of a great forest. When you walk among tall trees, your eyes are drawn upward toward the leaves dancing in the breeze. But hidden beneath your feet lies another world. A vast network of roots quietly supports every trunk. You cannot easily see those roots, yet the forest depends upon them. Dark matter may play a similar role, invisible, patient, quietly supporting the great architecture of the cosmos. Without that unseen framework, many galaxies would likely never have gathered into the beautiful structures we observe today. The glowing galaxies are like leaves. The invisible framework is like the roots. One is easily seen, the other quietly carries much of the weight. This idea may seem surprising at first, yet the universe often reminds us that not everything important is visible. You cannot see the wind itself, only the leaves it gently moves. You cannot see gravity, only the quiet paths followed by planets and stars. In much the same way, astronomers cannot directly see dark matter. Instead, they notice the graceful influence it leaves upon everything around it. The farther your imagination drifts, the more magnificent the cosmic web becomes. Its threads stretch across distances almost too large to picture. Clusters sparkle where many pathways meet. Long rivers of galaxies quietly extend through darkness. Immense peaceful voids rest between them like calm lakes beneath an endless night. From this extraordinary distance, even the Milky Way has become almost impossible to distinguish. Somewhere along one tiny thread, inside one modest group, around one ordinary star, a small blue planet quietly circles in silence. Home has not disappeared. It has simply become wonderfully small. And perhaps there is something deeply comforting about that. The worries carried through an ordinary day begin to feel lighter when placed beside a universe that has spent billions of years weaving such gentle patterns across unimaginable distances. Nothing in this grand design appears rushed. Everything unfolds with remarkable patience. Even now, the cosmic web continues its slow evolution, changing so gradually that an entire civilization could rise and fade without noticing even the slightest difference. The universe has mastered the art of moving slowly. Perhaps tonight, you can borrow just a little of that patience for yourself. And as your eyes continue to follow these quiet rivers of galaxies, stretching farther than imagination once believed possible, another gentle question begins to appear beyond them. If this magnificent web is the largest pattern we can see, how much farther does the universe continue beyond its delicate threads? And where, if anywhere, does our view finally begin to fade? The delicate threads of the cosmic web now stretch quietly behind you. The great rivers of galaxies, the glowing clusters, and the peaceful valleys between them slowly soften into one immense tapestry woven across the darkness. For a little while, you simply drift. There is no destination demanding your arrival, only another gentle question waiting patiently ahead. If the cosmic web is so vast, does it continue forever, or is there, somewhere beyond those distant galaxies, a quiet edge where the universe simply comes to an end? It is one of the oldest questions people have ever asked, and the answer is both simpler and far more beautiful than it first appears. To understand it, you do not need difficult mathematics. You only need a small lantern. Imagine standing alone in a wide, peaceful field after sunset. The night stretches endlessly in every direction. You lift a lantern into the darkness. Its warm light gently reaches the nearby grass. It touches a few trees standing farther away. Beyond them, however, the darkness remains, not because nothing exists there, simply because your lantern's light has not traveled that far. If the lantern were brighter, or if you waited long enough, its light would slowly continue outward. Little by little, more of the landscape would quietly appear. The universe behaves in a surprisingly similar way. Everything we know about distant space arrives through light. Not light in the sense of bright sunshine alone, but every gentle signal that travels across the cosmos, carrying tiny stories from distant places. Every galaxy you have ever seen, every colorful nebula, every quiet star, first introduced itself by sending light across unimaginable distances. Light is the universe's oldest storyteller. It never speaks loudly. It simply travels, patiently, faithfully, without stopping. Yet even light, remarkable as it is, does not move instantly. It travels incredibly fast, faster than anything else we know in nature. But the universe is so enormous that even this extraordinary messenger requires time. Sometimes a little time, sometimes millions of years, sometimes billions. Imagine receiving a letter written by someone who began their message before the first flowers ever bloomed on Earth. Only tonight does that letter finally arrive. That is, in many ways, what astronomers experience whenever they observe the distant universe. They are reading ancient messages. The farther away something is, the older the message becomes. Every telescope is, in its own quiet way, a machine for looking into history. When astronomers observe our neighboring Andromeda galaxy, they see it not exactly as it is today, but as it appeared about 2.5 million years ago. Its light has spent all that time crossing the quiet darkness between our galaxies. The galaxy itself has continued changing throughout those ages, yet only now has its old light gently reached us. If we look much farther away, the story becomes even more remarkable. There are galaxies so distant that the light arriving today began its journey when the universe itself was still very young, before our sun existed, before Earth formed, before oceans shimmered beneath moonlight, before life quietly learned to grow. Those tiny particles of light have traveled almost the entire history of the cosmos simply to arrive here tonight. One particularly distant galaxy, known to astronomers by a technical catalogue name, is often remembered simply as one of the earliest galaxies we have ever discovered. There is no need to remember its long scientific label. What matters is its journey. Its light has been travelling for more than 13 billion years. Imagine that for a moment. Not 13 years, not 13,000 years, but more than 13 billion years of uninterrupted travel, across darkness, across expanding space, across the changing universe itself. Only now does that ancient glow softly enter our telescopes. It is less like seeing a distant place, and more like opening a letter written near the beginning of time. Naturally, another question appears. If light has been travelling for such an astonishing length of time, how far can we actually see? The answer is what astronomers call the observable universe. The phrase sounds wonderfully technical, but its meaning is gentle. It simply describes everything whose light has had enough time to reach us since the universe began. Think again of your lantern in the quiet field. You can only see as far as the light has arrived. Beyond that distance, the landscape may continue. The hills may continue. The forests may continue. Perhaps even entire mountains lie hidden. You simply have not received their light yet. The observable universe is much like that illuminated landscape. It is not necessarily the entire universe. It is simply the part whose ancient light has had enough time to reach our little corner of space. Beyond that quiet horizon, there may be vastly more. Perhaps countless more galaxies. Perhaps endless stretches of the cosmic web. Perhaps regions unlike anything we have yet imagined. The honest answer is wonderfully peaceful. We do not know. And perhaps we are not meant to know just yet. There is something comforting about that uncertainty. In everyday life, we often feel pressure to have every answer. The universe asks something gentler of us. It reminds us that wonder can exist without certainty, that curiosity does not always require completion, that it is perfectly acceptable to rest beside a mystery without needing to solve it before morning. As your journey continues, you find yourself quietly floating near this invisible horizon. Not a wall, not a barrier, simply the gentle limit of what ancient light has been able to reveal. Beyond it, the universe may continue far beyond imagination. Yet even here, standing at the edge of everything humanity has ever observed, you cannot help but notice something remarkable. The horizon itself is changing. Very slowly, almost too slowly to imagine, the universe continues expanding, carrying distant galaxies farther away with every passing age. And that quiet motion will soon reveal another beautiful mystery, one that changes the future of every distant star we have yet to meet. You remain quietly suspended near the farthest reaches of everything humanity has ever observed. There is no great wall before you, no glowing boundary, no silent gate marking the edge of existence. Only distance. Distance so immense that even the oldest light has only just managed to arrive. For a while, nothing seems to move. The distant galaxies rest peacefully against the darkness, like tiny lanterns scattered across an endless evening landscape. Yet appearances can be wonderfully patient. Things that seem perfectly still are often moving in ways too slow for ordinary eyes to notice. Think of watching the shadow of a tree during a warm afternoon. For several minutes, it appears almost frozen. But if you return hours later, the shadow has quietly crossed the garden without making a sound. The universe moves in much the same gentle way. Its greatest changes happen so slowly that they become almost invisible to anyone living for only a human lifetime. Long ago, astronomers expected the universe to be rather still. Galaxies might move around one another. Stars might slowly orbit their galaxies. But on the largest scales, many imagined that the universe itself simply existed as it always had. Then, during the last century, careful observations began to reveal a remarkable surprise. The universe was not standing still at all. Instead, it was quietly expanding. That single word, expanding, can easily bring confusing pictures to mind. Some people imagine galaxies flying outward through empty space, almost like sparks bursting from a firework. But the reality is softer than that. Imagine placing tiny raisins inside a ball of bread dough. At first, every raisin rests peacefully beside the others. Then the dough begins to rise, very slowly, almost too slowly to notice. The raisins themselves are not racing through the dough. Instead, the dough between them is gently stretching. As the loaf grows larger, every raisin gradually finds itself farther from the others. The universe behaves in a surprisingly similar way. Galaxies are not simply rushing through an already empty stage. Rather, the stage itself is quietly growing. Space is gently stretching. Every enormous region becomes just a little larger than before. Every great distance slowly increases. Nothing dramatic happens from one moment to the next. The process is wonderfully calm. Imagine drawing tiny dots on the surface of a balloon. As the balloon slowly inflates, every dot drifts away from every other dot. No single dot sits at the center of the expansion. Each one simply notices that more space now exists between itself and its neighbors. The universe has no obvious center from which everything is fleeing. Instead, the expansion happens everywhere, quietly, all at once. You may wonder how astronomers discovered something so subtle. The answer arrived through light. Once again, light became the universe's faithful storyteller. When galaxies move farther away, the light they send gently changes during its long journey. Imagine listening to someone singing from a slowly departing boat. As the boat glides farther across a peaceful lake, the sound seems to deepen ever so slightly. The melody remains the same, yet it becomes softer and lower as distance grows. Light experiences a similar kind of stretching. As space itself expands, the gentle waves of light also become slightly longer during their journey. Astronomers call this effect redshift because the light gradually shifts toward the warmer red end of the rainbow. You do not need to remember that name tonight. It is enough to imagine light carrying tiny wrinkles across the universe. As space slowly stretches, those wrinkles stretch with it, like gentle ripples spreading farther apart across a quiet pond. By measuring this delicate stretching, astronomers discovered something extraordinary. Almost every distant galaxy appears to be moving farther away from us. Even more surprising, the farther a galaxy already is, the faster the growing universe gently increases the distance between us. Not because the galaxy is trying to escape, not because we occupy a special place, simply because more space exists between us every passing moment. It is a wonderfully peaceful idea. The universe is not rushing outward in panic. It is quietly unfolding, like a flower opening at sunrise, like mist slowly lifting from a quiet valley, like a long story revealing itself one gentle page at a time. As billions of years continue to pass, this expansion quietly changes what future civilizations may be able to see. Imagine once again standing beside your lantern in the endless field, except now, the field itself is slowly becoming larger. The distant hills gradually move farther away. The forests gently retreat toward the horizon. Some landscapes eventually become so distant that the lantern's light can no longer reach them. Not because they disappeared, but because the growing distance quietly carries them beyond your view. Something similar will happen across the universe. Many of the galaxies visible through today's powerful telescopes will slowly fade from future skies. Their ancient light will become increasingly stretched, increasingly faint, increasingly difficult to receive. Far enough into the future, countless distant galaxies may quietly slip beyond the observable horizon altogether. Future astronomers, living trillions of years from now, could look into the night and see a much lonelier universe than we do today. Not because those distant galaxies vanished, not because the cosmic web unraveled, simply because expanding space gently carried their light beyond reach. There is something unexpectedly tender about this thought. The universe reminds us that seeing is sometimes a matter of timing. We happen to live during an age when countless galaxies still share their ancient stories with us. We are listening while the letters are still arriving. One day, many of those letters will no longer reach this quiet little corner of the cosmos. But tonight, they still do. Tonight, the universe continues speaking, softly, patiently, across billions of years. And as you continue floating beside this ever-changing horizon, another even older whisper begins to emerge from the darkness. It is not the light of galaxies, not the glow of stars, but something far older still, a faint, gentle echo that has been traveling since the universe itself was very young, quietly carrying the oldest memory that light has ever preserved. As your thoughts slowly drift away from the farthest horizon that light can reveal, the universe begins to feel quieter once again. The enormous rivers of galaxies fade into the darkness. The delicate threads of the cosmic web become almost impossible to see. The vast expansion of space continues its patient unfolding somewhere beyond imagination, asking nothing more of you tonight. Instead of looking farther away, your attention now gently settles upon something much smaller, not because it is less important, but because even within this immense universe, the smallest rhythms often become the easiest to notice. Imagine standing beside a peaceful coastline long after midnight. The sea is perfectly calm. Above you, countless stars quietly decorate the sky. Far out on the horizon, almost too distant to recognize, a lighthouse slowly turns. Its bright beam sweeps across the ocean. For a brief moment, the light faces you. Then it slips away. Darkness returns. A few moments later, the light quietly returns again. Always patient, always steady, always keeping the same peaceful rhythm. The universe has its own quiet lighthouses. They are not built from stone. They are not watched by careful keepers. Instead, they are the remains of stars that finished one remarkable life and gently began another. Long before anyone knew these cosmic lighthouses existed, astronomers were quietly listening to the sky, not only with their eyes, but also with enormous radio telescopes. Unlike ordinary telescopes, which collect visible light, radio telescopes listen for gentle radio waves arriving from distant parts of the universe. You might think of them as giant ears resting beneath the open sky. They do not hear sound, of course. Space itself is almost completely silent. Instead, they patiently collect another kind of invisible signal, quietly translating it into patterns that scientists can study. One evening, during the late 1960s, a young graduate student named Jocelyn Bell was carefully examining long rolls of paper covered with tiny lines. Hour after hour, day after day, she searched for anything unusual. Most of the markings looked familiar, small variations, gentle background noise, nothing unexpected. Then one day, she noticed something different, a tiny signal, regular, precise. Unlike anything she had seen before, it appeared, disappeared, then appeared again with remarkable consistency. The rhythm was so exact that nobody immediately knew what could possibly create it. For a short time, the discovery inspired an amusing nickname. Some researchers jokingly referred to the mysterious source as "little green men," not because they truly believed visitors from another civilization had arrived, but because the signal seemed almost impossibly regular. Whatever produced it behaved with extraordinary precision. The playful name did not last for very long. As more of these mysterious signals were discovered across the sky, it became clear that nature itself had created them. No visitors were required, only stars, very unusual stars. To understand these remarkable objects, imagine a star much larger than our Sun, reaching the end of its long life. For millions of years, it shines peacefully, producing warmth and light. Eventually, however, its gentle balance begins to change. Its outer layers drift away into space. Its central regions collapse inward under their own immense gravity. The star does not simply disappear. Instead, it becomes something astonishingly compact. Imagine taking an entire mountain range, with all its valleys, forests, rivers, and rocky peaks, and somehow compressing it until everything fits inside a single grain of sand. Reality does not work exactly that way, of course, but the comparison gently hints at something important. An enormous amount of matter becomes packed into an extraordinarily small space. The result is called a neutron star. Despite being much smaller than the star that created it, a neutron star still contains an incredible amount of material. Its gravity remains extraordinarily strong. Its surface becomes unimaginably dense. Yet tonight, numbers are not what matter. What matters is the feeling. A once enormous star has quietly folded inward, becoming one of the smallest and most remarkable objects in the universe. Not every neutron star becomes a pulsar, only some do. These special stars spin, and they spin with extraordinary steadiness. Imagine once again the lighthouse beside the sea. Its bright lamp does not flash on and off. Instead, it shines continuously, while slowly rotating. From far away, anyone standing along the shoreline only sees the beam whenever it happens to sweep in their direction. Light, darkness, light, darkness. Again and again, a pulsar behaves in much the same gentle way. Invisible beams of energy stream outward from regions near the star's magnetic poles. As the star slowly, or sometimes astonishingly quickly, rotates, those beams sweep across space. If one of those beams happens to cross Earth, our telescopes notice a brief pulse, then silence, then another pulse. The star itself is not switching on and off. It is simply turning, like a patient lighthouse beyond the horizon. Some pulsars complete a single rotation in less than a second. Others turn more slowly. Each keeps its own quiet rhythm with astonishing reliability. If you could somehow listen to one for years, you would find its heartbeat remaining almost perfectly steady, as though the universe itself had discovered an endless metronome. There is something deeply comforting about that. Across billions of years, through darkness almost beyond imagination, a tiny star quietly continues turning, pulse after pulse, night after night, age after age. Its steady rhythm reminds us that endings are not always endings. Sometimes they are transformations. The brilliant star that once filled its corner of the galaxy with light has not completely vanished. Its story simply continues in another form, smaller, quieter, yet no less beautiful. As you rest beside these gentle cosmic heartbeats, another thought slowly begins to emerge. If a star can become so compact, if its quiet pulses can travel across the galaxy for millions of years, what might happen when one of these extraordinary stars carries an even more powerful invisible force, one so strong that it can quietly reshape the space around it itself? That answer waits patiently in the darkness ahead. The quiet heartbeat of the pulsar continues long after you stop counting its gentle rhythm. Pulse, silence, pulse, silence. It never seems hurried. It simply turns, patiently carrying the memory of a once brilliant star across the darkness. For a while, it feels as though every neutron star must behave this way. Steady, reliable, predictable. But the universe, as it often does, quietly reminds you that even familiar stories can have unexpected variations. Some neutron stars are born carrying something even more remarkable. Not brighter light, not greater size, not faster movement. Instead, they possess an invisible force so extraordinary that it quietly shapes everything around them. These rare objects are called magnetars. The name sounds almost mythical, yet it describes something entirely real. To understand a magnetar, imagine holding a simple compass in your hand. No matter where you stand on Earth, the tiny needle gently turns until it points toward our planet's magnetic field. It is such an ordinary experience that most people hardly notice it anymore. The magnetic field surrounding Earth is gentle. It quietly protects our atmosphere from many energetic particles arriving from the sun. It guides migrating birds across continents. It helps sailors and travelers find their direction. Most days, it works silently, asking for no attention at all. Now imagine that same invisible force becoming almost unimaginably stronger. Not just a little stronger, not hundreds of times stronger, but so immensely powerful that ordinary comparisons begin to lose their meaning. Tonight, there is no need to think about enormous numbers. Instead, imagine standing beside a quiet lake. You gently place one finger into the water. Small ripples spread peacefully across the surface. Now imagine dropping an enormous stone into that same lake. The ripples become waves. The entire surface responds. The difference between Earth's magnetic field and that of a magnetar is something like the difference between those two moments. One is gentle, the other quietly reshapes its surroundings. Yet even this comparison remains wonderfully incomplete. The invisible magnetic field surrounding a magnetar is believed to be the strongest naturally occurring magnetic field known anywhere in the universe. It cannot be seen with your eyes, It carries no color. It produces no graceful ribbons of light like the auroras dancing above Earth's polar skies. Instead, it quietly fills the space surrounding the star, extending outward like an invisible landscape. If you could somehow float nearby, a journey that exists only within imagination, you would notice nothing unusual at first. The star would appear small, dense, silent, yet hidden around it would be one of the most extraordinary environments nature has ever created. Fortunately, the nearest known magnetars remain safely far away. The universe is kind enough to place these remarkable objects at comfortable distances from our little blue world. From here, they become something to quietly admire rather than something to fear. Like distant thunderstorms seen beyond the horizon, beautiful because they remain far away. Like pulsars, magnetars are also neutron stars. They rotate, they emit energy. Some even produce regular pulses that astronomers patiently observe with powerful telescopes. But deep within these remarkable stars, another story is unfolding. Imagine an ancient tree growing slowly through many seasons. Its bark appears calm, its branches sway gently in the wind. Yet beneath the surface, the wood quietly changes year after year, responding to invisible stresses built over time. Eventually, a tiny crack may appear, not because the tree is weak, simply because nature continues its slow work. A magnetar experiences something surprisingly similar. Its outer surface, though unimaginably different from wood or stone, is believed to become strained by the powerful magnetic forces hidden inside. Over many years, those stresses slowly build. Then, every so often, the surface suddenly shifts ever so slightly. Astronomers sometimes describe these moments as starquakes. The name feels wonderfully familiar, like earthquakes beneath our own feet. Yet instead of rocky continents gently moving, it is the rigid outer layer of an extraordinary neutron star adjusting itself. The movement may last only a brief moment, but the energy released can travel across enormous distances. For a little while, the quiet star becomes unexpectedly bright in forms of light invisible to human eyes. Space observatories detect brief flashes arriving from far across the galaxy. These gentle outbursts have earned names such as soft gamma repeaters because they release repeated bursts of very energetic light. Others are known as anomalous X-ray pulsars, quietly reminding astronomers that nature does not always fit neatly into the categories people first create. The names themselves are not important tonight. What matters is the idea behind them. Even among neutron stars, every life remains unique. Every ending writes a slightly different story. Some become remarkably steady cosmic clocks. Others occasionally whisper through brief flashes that cross the galaxy before fading once more into silence. One of the most comforting discoveries about magnetars is that even they do not remain forever restless. Time, once again, becomes the universe's greatest quiet artist. As thousands of years pass, then tens of thousands, their tremendous magnetic fields slowly weaken, their energetic outbursts become less frequent, their invisible storms gradually calm. It is almost as though the star itself is slowly learning to rest. The fierce forces hidden within it gently settle. The extraordinary becomes ordinary once again. There is something deeply familiar about that rhythm, not because people become magnetars, but because almost everything in nature seems to move toward quietness if given enough time. Storms pass, oceans become calm, mountains slowly soften beneath wind and rain. Even some of the universe's most remarkable stars eventually drift towards stillness. Perhaps that is one of the gentlest lessons hidden among the galaxies. Nothing needs to remain intense forever. Even the strongest invisible storms eventually grow peaceful. As you continue floating through the darkness, leaving these remarkable stars behind, countless ordinary suns begin to quietly fill your imagination once more. Most stars are nothing like pulsars. Most never become magnetars. Instead, they spend unimaginably long lives shining softly, warming the worlds that circle around them. And somewhere ahead, surrounding one small, quiet red star, waits a family of gentle planets that has invited people everywhere to wonder what peaceful evenings beneath another sky might feel like. The invisible storms of the magnetars slowly fade behind you. Their powerful magnetic fields become quiet memories, resting somewhere deep within the great tapestry of the universe. Ahead, the darkness begins to soften once more, not because another spectacular explosion is waiting, not because another mystery demands an answer, but because you are approaching something wonderfully ordinary, a small star, one among countless billions. And yet, around this modest little sun, nature has arranged one of its most graceful planetary families. Imagine arriving at a peaceful cottage on a cold winter evening. At the center of the room, a small fireplace glows with gentle warmth. Around it, 7 lanterns rest in quiet circles. Each lantern sits at its own comfortable distance. None rushes, none wanders away. Together, they move in a calm rhythm that has lasted for ages. The TRAPPIST-1 system feels something like that. Far from Earth, nearly 40 light-years away, shines a star so small that, compared with our own sun, it almost seems shy. It does not blaze with brilliant white light. It does not dominate its surroundings with overwhelming brightness. Instead, it glows softly with a deep reddish color. Astronomers call stars like this red dwarfs. The name sounds almost playful, and in many ways it fits. Red dwarfs are the quiet neighbors of our galaxy. They are smaller than our sun, cooler than our sun, much less luminous than our sun. If our sun is like a bright summer afternoon, a red dwarf feels more like the gentle glow of a fireplace after sunset. Its warmth is softer, its light is calmer, its presence is wonderfully patient. Because these stars burn their fuel very slowly, they can continue shining for astonishing lengths of time, far longer than stars like our own. Tonight, though, it is not the star itself that quietly captures your imagination. It is the family gathered around it, 7 planets, each roughly similar in size to Earth, each moving peacefully around the same small star. When astronomers first confirmed the existence of all 7 worlds, it felt almost like opening a carefully wrapped gift. 1 planet was exciting. 2 seemed remarkable. 7 altogether felt almost unbelievable. Yet the universe had quietly arranged them long before anyone on Earth knew where to look. If you could drift above this distant system, you would notice something unusual. The planets travel remarkably close to their star, closer than Mercury orbits our own Sun. At first, this might sound far too close for comfort. After all, moving so near our Sun would create unbearable heat. But TRAPPIST-1 is much cooler. Its gentle light allows its planets to nestle close without necessarily becoming scorching worlds. Imagine gathering around a campfire on a chilly evening. The fire itself is small. If you stand too far away, you hardly feel its warmth. To become comfortable, you naturally move a little closer. The planets of TRAPPIST-1 have done something similar. Their little sun simply asks them to stay nearby. Among these 7 worlds, several orbit within what astronomers often call the habitable zone. The phrase may sound technical, yet its meaning is beautifully simple. It is the region around a star where temperatures might allow liquid water to exist on a planet's surface. Not too warm, not too cold, somewhere gently between the two. Much like finding the most comfortable blanket on a cool evening. Not so thick that you overheat. Not so thin that you feel the cold. Just enough. Scientists cannot yet say whether these planets truly possess oceans, or clouds, or gentle rainfall beneath quiet skies. Those answers remain hidden for now, but the possibility itself quietly inspires the imagination. Perhaps somewhere on one of these distant worlds, rain softly falls onto ancient rocks. Perhaps calm seas reflect a dim red sunrise. Perhaps frozen valleys slowly warm beneath a patient morning sky. Or perhaps these planets remain silent, beautiful landscapes where only the wind moves across empty plains. The truth waits peacefully beyond our current knowledge. There is no need to hurry toward it. One of the loveliest features of the TRAPPIST-1 family lies not in the planets themselves, but in the graceful rhythm of their journeys. They do not simply circle their star without care. Instead, their orbits are gently connected. Imagine 7 musicians sitting together in a quiet room. No one rushes ahead. No one falls behind. Each listens carefully to the others. Every note fits naturally into the next. The result is not perfect sameness. It is harmony. The planets of TRAPPIST-1 share a similar relationship. Their orbits form delicate patterns that astronomers describe as orbital resonance. There is no need to remember those words tonight. Simply picture 7 dancers quietly moving across a polished floor. Each step helps guide the next. Each movement supports the entire dance. Together, they create a peaceful rhythm that has endured for countless ages. Nature often seems to enjoy this kind of quiet balance. Again and again, across the universe, gentle patterns appear where chaos might have been expected. Stars gather into galaxies. Galaxies gather into clusters. Planets gather into graceful families. The same patient hand of gravity quietly arranges them all. As you drift among these 7 worlds, each one feels like a chapter in a story that has not yet been read. Some may be rocky, some may carry deep oceans, some may possess thin atmospheres whispering beneath distant skies. Others may have long ago lost much of the air surrounding them. Each world quietly keeps its own secrets. Even the most powerful telescopes cannot yet reveal every detail. Instead, they offer gentle hints, tiny shadows crossing a distant star, subtle changes in light, small clues patiently collected over many years. Astronomy often feels less like solving puzzles and more like listening to whispers carried across enormous distances. There is something deeply comforting about that. The universe does not reveal everything at once. It shares its stories slowly, piece by piece, century after century, discovery after discovery. And perhaps that makes every quiet answer feel even more precious. As the little red sun continues glowing softly behind its family of peaceful planets, you cannot help but notice another remarkable truth. Stars like TRAPPIST-1 are not rare at all. In fact, they may be the most common stars in our galaxy. Tiny, patient, long-lived, quietly shining while much larger stars come and go. And if these gentle little suns are scattered almost everywhere throughout the Milky Way, then perhaps the galaxy is filled with countless more small worlds, peacefully circling dim red fires beneath the endless night. The little family of worlds surrounding TRAPPIST-1 slowly fades behind you. Its 7 quiet planets continue their graceful dance, circling their gentle red sun just as they have for ages. Nothing asks them to hurry. Nothing asks them to become brighter. They simply continue, steadily, patiently. As you drift farther through the quiet darkness, you begin to notice something surprising. Stars like TRAPPIST-1 are everywhere, not dazzling giants, not brilliant blue suns that briefly command attention before fading away. Instead, countless tiny red stars quietly fill the galaxy. They are easy to overlook. Many are too faint to be seen without careful instruments. If our own sun is like a cheerful singer standing at the center of a stage, these little stars are more like quiet readers sitting beside warm windows, content to spend long evenings turning one page at a time. They ask for very little, yet they have extraordinary stories to tell. Astronomers call them red dwarfs. The name sounds modest because they truly are modest stars. They contain much less material than our sun. They shine with only a small fraction of its brightness. Their gentle reddish glow seems almost shy against the deep black of space. And yet, appearances can be wonderfully misleading. Sometimes the smallest things endure the longest. Imagine lighting 2 candles. One is large, with a broad, dancing flame. It fills the room with bright golden light. The other is much smaller. Its flame is gentle, quiet, barely moving. Hours pass. The larger candle gradually melts away. Its bright flame slowly shortens. Eventually, only a little wax remains. The smaller candle, however, has been burning so carefully that it hardly seems to have changed at all. Nature often works in much the same way. Large stars live dramatic lives. They burn their fuel quickly. They shine brilliantly. They create breathtaking colors across the universe. But such brilliance comes with a quiet cost. The brighter a star shines, the faster it uses the fuel hidden deep within its heart. A red dwarf chooses another path. It burns slowly, patiently, almost reluctantly. Deep inside every ordinary star, tiny particles come together under immense pressure, quietly releasing energy. That energy slowly works its way outward through layer after layer, before finally escaping into space as warmth and light. The process never rushes. It unfolds with extraordinary patience. Inside a red dwarf, this gentle transformation happens at a much calmer pace than it does inside larger stars. Imagine cooking a meal over a roaring fire. The food cooks quickly. The wood disappears just as quickly. Now imagine preparing the very same meal over gentle glowing coals. Everything takes longer. The heat is softer. The fuel lasts far into the evening. Red dwarfs are like those quiet glowing coals. They use their precious fuel so carefully that they can continue shining for periods almost beyond imagination. Our own sun is expected to spend roughly 10 billion years peacefully shining before entering the next stage of its life. That number alone feels enormous, longer than human history, longer than mountains have stood in their present form, longer than almost anything familiar to us. Yet many red dwarfs may continue shining not for 10 billion years, but for trillions of years. The word trillion is one we rarely encounter in everyday life. There is no need to picture the number itself tonight. Instead, imagine reading every book in every library on Earth, one page at a time, without ever rushing, then beginning again. Even that quiet journey would hardly hint at such extraordinary lengths of time. The universe is wonderfully patient, and red dwarfs seem to understand that patience better than almost anything else we have discovered. In fact, something rather remarkable follows from this quiet way of living. The universe itself is not yet old enough for a single red dwarf to have completed its entire natural life. Every red dwarf that has ever been born is still quietly shining today. Not one has reached the peaceful ending that astronomers expect will eventually come. It is a beautiful thought. Across the Milky Way, countless tiny stars have spent the entire history of the universe gently glowing, asking for almost nothing except time. Some may continue shining long after our sun has completed its own story, long after the familiar constellations above Earth have slowly changed, long after many galaxies have drifted beyond our observable horizon. They will simply continue, steadily, patiently, like quiet lanterns left glowing through an unimaginably long night. If one of the peaceful planets surrounding TRAPPIST-1 could somehow watch the future unfold, generation after generation might pass beneath its skies, while the little red sun above remained almost unchanged. Mountains could slowly erode. Oceans might quietly reshape distant coastlines. Entire civilizations, if any should ever arise, could write histories stretching beyond imagination. Yet overhead, the same gentle star would still glow. There is something deeply comforting about such reliability. In our own lives, so much seems to change. Days become seasons, seasons become years. Faces grow older, children become parents, cities slowly transform. The universe, however, reminds us that some things are content to move almost beyond the reach of change itself. Perhaps that is why these tiny stars feel strangely peaceful. They are in no hurry to become anything else. They simply remain what they already are, warm, quiet, patient. Even so, no story continues forever. Time eventually reaches everything. Although no red dwarf has yet grown old enough for astronomers to witness its final chapter, careful studies suggest that even these gentle stars will one day change. Not tomorrow, not for billions of years, not even for many trillions, but someday. The smallest candles, too, eventually finish their slow burning. That distant ending belongs to an age so unimaginably far ahead that the universe itself will look entirely different. For tonight, however, the little red stars continue shining exactly as they always have. They ask nothing from the darkness, except the freedom to glow quietly for a little longer. And as you leave these patient little suns behind, your thoughts begin to wander toward another family of stars altogether. Larger stars, brighter stars, stars that choose a very different rhythm. They live faster, they shine more brilliantly, and when their long journeys finally reach their quiet conclusion, they leave behind some of the most mysterious objects the universe has ever imagined. The tiny red stars slowly disappear into the quiet distance behind you. They continue their patient lives, burning gently through ages almost too long to imagine. There is something comforting about knowing they will remain there, quietly shining while entire chapters of the universe slowly unfold around them. Yet not every star chooses such a peaceful rhythm. Some stars live differently, not recklessly, not carelessly, simply differently. Imagine walking through a vast forest. Some trees are slender and slow-growing, quietly adding one delicate ring each passing year. Others rise quickly toward the sunlight. Their trunks grow broad. Their branches spread wide across the sky. For a time, they seem almost impossible to overlook. But those great trees often complete their lives sooner than the smaller ones patiently growing beneath them. The universe follows a surprisingly similar pattern. Large stars are magnificent. They shine with extraordinary brilliance. Their light reaches astonishing distances across space. If you could stand safely beside one, its glow would fill the heavens with colors beyond anything seen from Earth. Yet that brilliance quietly comes with a promise. The brighter a star shines, the faster it gently spends the precious fuel hidden within its heart. Every star begins its life in much the same way. Deep inside enormous clouds of drifting gas and dust, gravity patiently gathers tiny particles together. Little by little, the growing cloud becomes denser, warmer, brighter. Eventually, a new star quietly awakens. Its long journey begins. For millions, or billions of years, depending on its size, the star remains balanced. Gravity gently pulls inward. The energy produced deep within gently presses outward. Neither force rushes to win. Instead, they create a peaceful harmony that allows the star to shine steadily across the darkness. Our own sun is living during this calm chapter today. So are countless other stars scattered across the Milky Way. But eventually, every story reaches a moment when change quietly arrives. Inside the star, the easiest fuel slowly becomes more difficult to find. The peaceful balance begins to shift. For smaller stars, like the quiet red dwarfs you recently visited. This transformation happens almost unimaginably slowly. For larger stars, however, the story begins to move more quickly. Imagine an old fireplace during a long winter evening. At first, dry logs burn warmly and steadily. Hours later, only glowing embers remain. The fire still gives warmth, but something has changed. The brightest flames have quietly disappeared. A massive star experiences a similar turning point. Its inner regions begin searching for new ways to continue producing energy. Layer after layer changes. The star gently transforms from within. For a while, it grows even larger. Its outer layers slowly expand into the surrounding darkness. If our sun were able to speak during such a transformation, perhaps it would simply whisper that it was stretching after an unimaginably long day. Then, after millions of years of quiet change, something remarkable happens. The balance that held the star together for so long can no longer be maintained. Gravity, which had patiently waited throughout the star's entire life, finally begins to take the lead. Everything starts moving inward, not because gravity suddenly became stronger. It had always been there. It simply no longer faced enough outward pressure to hold it back. The collapse happens astonishingly quickly compared with the peaceful life that came before it. The enormous star falls inward under its own weight. Then, almost in a single breathtaking moment, the outer layers rush outward into space. Astronomers call this magnificent event a supernova. The word sounds dramatic. Yet tonight, perhaps it is kinder to imagine something quieter. Picture an old dandelion standing in a peaceful meadow. A gentle breeze arrives. Its tiny white seeds drift away in every direction. The flower is no longer what it once was. Yet its story continues, carried outward by countless delicate travelers. A supernova does something surprisingly similar on a cosmic scale. It scatters material across space. Elements that were patiently created deep inside the star begin long new journeys through the galaxy. Some eventually become part of distant clouds. Some may help form future stars. Some may gather into new planets. Long ago, before Earth even existed, ancient stars quietly shared their material with the galaxy in exactly this way. The iron flowing through your blood, the calcium resting inside your bones, the oxygen filling each gentle breath. All were once created inside stars that completed their own quiet journeys long before our sun was born. There is something deeply comforting about that thought. The universe wastes very little. It transforms. Again and again, what seems like an ending often becomes the beginning of another story. After the brilliant light of a supernova slowly fades, something remarkable remains. If the original star was large, but not among the very largest, its central core may become a neutron star. You have already met some of these extraordinary objects. Some quietly pulse like distant lighthouses. Others carry invisible magnetic storms across the galaxy. But some stars begin their lives with even greater mass. When their final collapse arrives, gravity continues pulling inward, beyond the point where a neutron star can remain stable. The shrinking continues. The star becomes smaller, denser, more compact. until, according to our current understanding of nature, a boundary quietly forms around it. Beyond this invisible boundary, gravity becomes so strong that even light can no longer easily escape. The star has not vanished. It has become something entirely new, a stellar black hole. The name may sound dark, almost frightening, yet black holes do not roam the galaxy searching for things to swallow. They do not behave like enormous cosmic vacuum cleaners. Instead, they quietly follow the same gentle laws of gravity that guide every planet, every moon, every galaxy you have visited throughout this journey. Most spend their existence in remarkable silence, invisible, patient, quietly moving through the Milky Way, carrying the memory of the brilliant star they once were. There is a certain beauty in that transformation. The brightest stars often leave behind the darkest remnants. The loudest chapters give way to the quietest endings, and sometimes those quiet endings become the beginning of mysteries far deeper than anyone first imagined. As you continue drifting through the peaceful darkness, one thought gently remains with you. Somewhere near the center of almost every great galaxy waits a black hole unlike these stellar remnants, not born from a single star, but vastly larger, older, more mysterious, patiently resting at the heart of entire galaxies, quietly shaping the movements of billions of stars around them. The quiet remains of the great stars slowly drift behind you. Some have become gentle neutron stars, patiently turning like distant lighthouses. Others have quietly folded inward, becoming stellar black holes that move unseen through the Milky Way. For a little while, it feels as though you have reached the end of the story. After all, what could be more mysterious than a star becoming invisible? Yet the universe has another quiet surprise waiting. Imagine walking through an enormous forest before sunrise. The trees stretch farther than you can see. Birdsong has not yet begun. Everything feels calm. As you wander deeper, you notice something curious. Every tree, no matter where it stands, seems connected beneath the soil by an intricate network of roots. You cannot see those roots. You only notice their quiet influence. They help hold the forest together. They carry water. They patiently support life above the ground. The centers of galaxies are a little like those hidden roots. From a distance, a galaxy appears to be a graceful collection of stars. Beautiful spiral arms slowly curve outward. Clouds of glowing gas drift between countless suns. Everything seems balanced. Everything seems peaceful. But deep within that calm beauty, hidden at the very heart of the galaxy, rests something extraordinary. Not a single bright star, not a cluster of planets, but an enormous black hole. Astronomers now believe that nearly every large galaxy contains one, including our own. This realization did not arrive all at once. For many years, scientists carefully observed the stars near the center of the Milky Way. Those stars behaved in a very curious way. Instead of wandering gently through space, they raced around an apparently empty point. Some completed their journeys in only a few years. Others followed graceful elliptical paths that repeatedly carried them close to the mysterious center before drifting outward again. Imagine watching autumn leaves floating around a quiet whirlpool in a slow-moving river. You cannot immediately see what lies beneath the surface, yet every leaf quietly reveals its presence through its motion. The stars near the center of our galaxy told a similar story. Something invisible possessed an extraordinary amount of gravity. Whatever rested there had to contain an immense amount of matter gathered into an astonishingly small region. Slowly, patiently, year after year, observations became more precise. The conclusion grew increasingly difficult to avoid. At the heart of the Milky Way lies a supermassive black hole. Astronomers call it Sagittarius A star. The name comes from the constellation in whose direction it appears when viewed from Earth. Although it occupies the center of our galaxy, it is almost impossible to see directly, not because it is hiding, but because enormous clouds of dust lie between Earth and the galactic center, softly veiling much of the visible light. Even without seeing the black hole itself, astronomers learn to understand it by watching the graceful dance of the stars nearby. Those stars became quiet storytellers. Every orbit whispered another clue. Every careful observation slowly completed another piece of the puzzle. One particular star became especially important. Astronomers watched it patiently for many years as it traced a complete path around the invisible center. Its journey revealed that something unimaginably massive occupied that tiny region of space. And yet, despite possessing such extraordinary gravity, the black hole remained surprisingly peaceful. It did not consume the entire galaxy. It did not pull every nearby star inward. The Milky Way continues to exist much as it always has. Its spiral arms continue turning. New stars continue forming. Planets continue circling distant suns. Our own solar system quietly completes another orbit around the galaxy every few 100 million years, scarcely disturbed by the giant resting at its center. This is one of the most comforting truths about black holes. They obey gravity. Nothing more. If our sun were magically replaced by a black hole with exactly the same mass, a purely imaginary thought, and certainly not something that could naturally happen, Earth would continue following almost exactly the same orbit. Our planet would not suddenly be swallowed. The warmth and light of the sun would disappear, making life impossible, but gravity itself would remain nearly unchanged. Black holes are powerful. They are not magical. Far beyond the Milky Way lies another remarkable galaxy, known as Messier 87, often shortened simply to M87. From Earth, it appears as a soft, glowing island of light among countless others. At its center rests another supermassive black hole. This one is vastly larger than the one inhabiting our own galaxy. For generations, astronomers could only imagine what such an enormous object might truly look like. After all, how do you photograph something that does not allow light to escape? The answer required patience on a planetary scale. Instead of building one impossibly large telescope, scientists joined observatories across Earth into a single worldwide collaboration. Together, these distant instruments worked as though they were parts of one enormous eye. This remarkable effort became known as the Event Horizon Telescope. Its purpose was not to photograph the black hole itself. That would be impossible. Instead, it sought to capture the glowing material gently circling just outside the point where light could no longer escape. When the first image was finally revealed, the world saw something quietly beautiful, a soft ring of glowing light surrounding a dark central shadow, not a hole in space, not a cosmic monster, simply the graceful outline of gravity revealing its presence. The image was slightly blurred, gentle, almost dreamlike. Perhaps that felt appropriate. After all, humanity was looking toward one of nature's deepest mysteries from 55 million light-years away. There was never going to be a perfectly sharp portrait, only a patient glimpse, a quiet greeting across unimaginable distance. There is something deeply moving about that achievement. Thousands of people, many nations, many telescopes, working together not to conquer the universe, but simply to understand one small part of it a little more clearly. The universe often rewards patience more generously than speed. As you continue drifting through the calm heart of the galaxy, the supermassive black hole remains almost perfectly still. Stars continue their graceful orbits. Clouds of gas slowly wander nearby. Time itself seems to move more quietly here. Yet every so often, in distant galaxies across the cosmos, these giant black holes awaken. Material begins falling gently toward them. The surrounding gas grows brilliantly hot. Light pours across the universe with astonishing intensity. For a little while, the quiet giant becomes one of the brightest objects in existence. And those extraordinary beacons, shining across billions of light years, are known by one beautifully mysterious name: quasars. The great black hole at the heart of the galaxy remains almost perfectly still. Around it, stars continue their graceful journeys. Clouds of gas drift quietly through the galactic center. Nothing appears hurried. Nothing appears violent. If you watched this peaceful scene for thousands of years, you might notice almost no change at all. The giant simply waits, patiently, silently, as though time itself moves more slowly in its presence. For many galaxies, this quietness lasts for millions of years, sometimes even longer. A supermassive black hole does not spend every moment gathering material from its surroundings. Much of the time, it simply rests, invisible, hidden among billions of stars that gently circle its unseen home. But every so often, nature arranges the galaxy differently. A cloud of gas slowly wanders too close. Perhaps two stars pass near one another, gently disturbing the paths of drifting material. Perhaps another small galaxy quietly merges with its larger neighbor, carrying fresh clouds of gas toward the galactic center. Nothing happens suddenly. Nothing rushes. Gravity simply continues doing what it has always done, patiently inviting matter to move inward. Imagine a peaceful stream flowing through a quiet forest. For most of the year, only a little water trickles toward the center of the valley. The stream remains calm, barely noticeable. Then the seasons gently change. Snow melts high in the mountains. More water slowly arrives. The little stream becomes broader. Its surface catches the morning sunlight. Without becoming wild, it simply grows brighter. Something surprisingly similar happens around a supermassive black hole. The black hole itself remains invisible, but the material slowly falling toward it begins an extraordinary journey. Tiny grains of dust, clouds of gas, occasionally even wandering stars that drift too close. None of them fall straight inward. Instead, they begin circling, round and round, closer with every quiet orbit. Gradually, this swirling material forms a broad, glowing disk surrounding the hidden black hole. Astronomers call this beautiful structure an accretion disk. The name sounds wonderfully technical. Tonight, perhaps it is easier to imagine a slow whirlpool beneath autumn leaves. The leaves circle gently. Each journey carries them a little closer to the peaceful center. The water itself becomes smooth, ordered, graceful. The material surrounding a black hole behaves in much the same way. As those clouds continue circling, something remarkable begins to happen. The particles gently brush against one another. Little by little, they create heat. Not because they are crashing violently, but because countless tiny interactions slowly build warmth over time. Imagine rubbing your hands together on a cold evening. At first, almost nothing changes. Then, gradually, warmth begins to appear. The swirling disk around a supermassive black hole experiences something similar. Its quiet motion slowly becomes incredibly hot. So hot, in fact, that it begins shining brilliantly across many different forms of light. Visible light, ultraviolet light, X-rays, other gentle messengers that travel across the universe. Suddenly, something astonishing has happened. The black hole itself remains completely dark, yet everything surrounding it has become one of the brightest regions in the entire cosmos. It is rather like watching a campfire through a thick morning mist. You may never clearly see the glowing logs themselves. Instead, the surrounding fog becomes filled with warm golden light. The source remains partly hidden. Its presence is revealed by everything nearby. This is the quiet beauty of a quasar. A quasar is not the black hole itself. It is the brilliant neighborhood surrounding a supermassive black hole while it is actively gathering material. For a little while in its extraordinarily long life, the sleeping giant awakens, not with anger, not with violence, simply with light. The word quasar was created many years ago when astronomers first noticed these mysterious objects through their telescopes. From Earth, they appeared almost like ordinary stars, tiny points of light. Yet something about them seemed unusual. They were astonishingly bright, far brighter than any single star should ever be. Only later did careful observations reveal the truth. These were not nearby stars at all. They were the brilliant hearts of galaxies unimaginably far away. Some quasars shine from distances so enormous that their light began its journey before Earth had fully become the world we know today. The photons reaching our telescopes tonight may have traveled for more than 12 billion years. Throughout that extraordinary journey, they quietly crossed expanding space, passed through the growing cosmic web, and continued onward without losing their patient determination. When they finally arrive, they bring us a gentle memory from the early universe. In a way, every quasar is like a lighthouse whose beam has crossed an entire cosmic ocean. Its light left home long before humanity existed, Only now does it softly arrive upon our shores. Some quasars do something even more remarkable. From the regions near the black hole, narrow streams of energetic particles are gently launched into space. Astronomers often call these jets. The word may suggest something loud or explosive, yet from the vast distances separating us, they appear almost serene. Imagine sunlight streaming through tiny openings in the clouds after rain. Long columns of light quietly stretch across the sky. The cosmic jets of a quasar feel a little like those peaceful rays. They extend for astonishing distances, quietly carrying energy far beyond the center of the galaxy. Even here, however, patience remains the universe's favorite language. A quasar does not shine forever. Eventually, the surrounding gas becomes scarce. The swirling disk slowly grows thinner. Less material reaches the waiting black hole. Little by little, the extraordinary brightness fades. The great lighthouse quietly dims. The galaxy returns to the peaceful rhythm it knew before. Its stars continue their graceful orbits. New stars quietly form. Old stars gently age. The supermassive black hole rests once again beneath the calm heart of its galaxy. Perhaps our own Milky Way experienced such a brilliant chapter long ago. If so, it ended billions of years before human eyes ever looked upward. Tonight, our galactic center is wonderfully quiet, a sleeping giant beneath a peaceful sky. There is something deeply comforting about that thought. Even the brightest chapters of the universe are temporary. Even extraordinary brilliance eventually softens into calm. The cosmos never seems afraid of becoming quiet again. As you continue drifting beyond these ancient beacons of light, another gentle question slowly rises from the silence. If galaxies throughout the universe have spent billions of years creating stars, if countless planets quietly circle those stars, and if the universe has had so much time to tell its story, why does the night still feel so wonderfully silent? The brilliant quasars slowly fade into the distance. Their ancient light continues traveling through the expanding universe, quietly crossing oceans of space, long after the galaxies that created them have changed beyond recognition. Darkness gently returns. Not an empty darkness, a listening darkness. For the first time in your journey, you become aware not only of the things you can see, but of the enormous silence resting between them. Stars shine, galaxies slowly turn, planets quietly circle their suns, and between all of them stretches an almost endless stillness. It is here that another chapter of the universe quietly begins, not with brighter telescopes, not with faster spacecraft, but with listening. Imagine sitting beside a peaceful lake long after sunset. The water is perfectly smooth. No wind disturbs its surface. Somewhere far beyond the opposite shore, you believe there may be another traveler. You cannot see them. You cannot know whether they are truly there. So you simply listen. Perhaps, if the night remains calm enough, a distant bell may gently ring across the water. You do not expect it. You do not demand it. You simply remain patient. For many astronomers, the search for other civilizations feels remarkably similar. The universe is unimaginably large. Its stars are separated by distances so immense that even light, moving with extraordinary speed, requires years, centuries, or even millennia to travel between them. Messages, if they exist, would need the same patient journey. Nothing in the cosmos arrives quickly. This search has quietly become known as the search for extraterrestrial intelligence. People often shorten those words into a simple name, SETI. The letters themselves are not especially important tonight. What matters is the gentle idea behind them, listening, patiently, respectfully, without assuming that anyone must answer. Instead of pointing telescopes toward visible light alone, astronomers also observe the universe through radio waves. These gentle signals travel across enormous distances. They pass through clouds of dust that would otherwise hide much of the galaxy from view. Our own civilization has been quietly filling nearby space with radio signals for a little more than a century. Television broadcasts, radar, communications, tiny ripples spreading outward through the darkness. If another civilization happened to exist nearby, and if they possessed instruments similar to ours, they might notice that faint expanding bubble of radio light. Likewise, we sometimes wonder whether another world may already have sent similar whispers into the galaxy long ago. Perhaps they, too, simply hoped someone might be listening. This possibility inspired generations of scientists to build sensitive radio telescopes. Some resemble enormous bowls resting peacefully in quiet valleys. Others stretch across wide plains, working together like many ears listening to the same distant melody. Day after day, night after night, they quietly collect faint signals arriving from across the universe. Most of what they hear comes from nature itself. The gentle radio glow of distant galaxies, the quiet activity of stars, the soft background whispers left over from the early universe. Everything contributes to the great conversation of the cosmos. Then, every so often, something unusual appears. One of the most famous moments arrived during a warm summer in the late 1970s. A radio telescope detected a remarkably strong signal, unlike the ordinary background it usually received. It lasted for only a short time, then it quietly disappeared. The astronomer studying the data became so surprised that he circled the signal on the printed page and wrote one simple word beside it: "Wow." From that moment onward, people remembered it as the "wow" signal. Even today, no one knows with complete certainty what created it. Perhaps it came from an unusual natural event. Perhaps it resulted from something far more ordinary that simply has not repeated. Perhaps another explanation still waits to be discovered. The universe has remained politely silent on the matter. There is something surprisingly comforting about that uncertainty. Not every mystery demands an immediate answer. Sometimes the unanswered questions become gentle companions rather than frustrating puzzles. The night sky has always been generous with mysteries. Perhaps that is part of its quiet beauty. As technology has improved, astronomers have continued listening. The telescopes have become more sensitive. Computers have learned to recognize delicate patterns hidden among enormous oceans of data. New planets have been discovered around distant stars. Entire families of worlds, like TRAPPIST-1, quietly remind us that planetary systems may be common throughout the galaxy. With every discovery, the possibility gently grows. Not certainty, only possibility. And perhaps possibility is enough. Imagine standing once more beside the quiet lake. You still have not heard the distant bell, yet you now know there are many more shores than you first imagined, many more forests, many more quiet places where another traveler might someday choose to ring one small bell into the darkness. That knowledge alone changes the feeling of the night. The silence no longer feels empty. It feels spacious. The universe is astonishingly old. Some civilizations, if they exist, might be far younger than ours. Others might have begun their stories millions of years earlier. Some may have already faded away before Earth even formed. Others may not yet have reached the moment when they first look upward and wonder whether anyone else is listening. Time itself quietly separates us. Even if two civilizations exist within the same galaxy, they may simply live during different chapters of its immense history. It is rather like two people visiting the same peaceful beach. One arrives at sunrise, the other comes long after sunset. Both stand upon the same shore, both gaze across the same sea. Yet neither ever meets the other. The universe often reminds us that distance is not measured only in space. Sometimes it is measured in time. As you continue drifting through this vast silence, the stars around you seem almost to listen as well. Their ancient light quietly crosses the darkness. Their planets continue circling in patient rhythm. The great galaxies turn without haste. Everything feels wonderfully calm. And yet, despite the countless stars, the countless worlds, and the unimaginable age of the cosmos, one gentle question continues floating beside you. If the universe has had so many opportunities to fill itself with voices, why does it still seem so peacefully quiet? That question has lingered in the minds of scientists for generations. It has no final answer, only thoughtful possibilities. And together, they have come to be known as one of the most beautiful mysteries in all of science. The universe continues listening. Stars quietly shine. Galaxies slowly turn. Ancient light crosses unimaginable distances without ever growing impatient. You too remain quietly still, floating among the countless suns of the Milky Way. There are so many of them, far more than anyone could count in a lifetime. Around many of those stars, planets gently circle. Some are large, some are small. Some may be wrapped in thick clouds. Others may carry frozen landscapes beneath distant skies. Some, perhaps, quietly resemble the little blue world where this journey first began. When you consider all of this together, another thought naturally appears. If the universe has so many stars, and so many planets, and so much time, why has everything remained so wonderfully quiet? This gentle question has become known as the Fermi paradox. The name honors the physicist Enrico Fermi, who once asked a remarkably simple question during an ordinary conversation with friends. If intelligent civilizations should be common throughout the galaxy, where is everybody? The question itself is short. The silence following it has lasted for generations. Perhaps, though, it is kinder not to think of it as a paradox tonight. Instead, imagine standing in a vast forest just before sunrise. Fresh snow covers the ground. Every branch rests beneath a soft white blanket. Nothing moves, no birds sing, no wind stirs the trees. The forest is not empty, it is simply quiet. There is a difference. Silence does not always mean absence. Sometimes it simply means waiting. Scientists have spent many years quietly exploring different possibilities, not to prove one answer, but to understand how many gentle paths nature might choose. One possibility begins with humility. Perhaps worlds like Earth are much rarer than we first imagined. The universe may contain countless planets, yet the delicate combination of conditions needed for oceans, stable climates, protective atmospheres, and billions of years of peaceful evolution could be surprisingly uncommon. Imagine scattering millions of tiny seeds across an enormous valley. Many fall onto stone, others land in dry sand. Some are carried into rivers. Only a few happen to settle into rich, welcoming soil where they quietly grow into forests. Life may work in much the same gentle way. Not impossible, simply precious. Astronomers sometimes describe this perspective as the rare Earth idea. It does not claim that life cannot exist elsewhere, only that the long chain of fortunate circumstances leading to complex life may be more delicate than we currently understand. There is something strangely comforting about this thought. It reminds us that our own world, with its blue oceans, gentle rain, drifting clouds, and living forests, is worthy of quiet gratitude. Another possibility looks not toward planets, but toward time itself. Perhaps many civilizations begin their stories, yet only a very small number continue for extraordinarily long periods. Some may quietly disappear before learning to communicate across the stars. Others may face challenges unique to their own worlds. Natural changes, shifting climates, asteroids. The choice is made by intelligent beings themselves. Scientists sometimes gather these unknown challenges beneath a thoughtful idea called the Great Filter. The phrase sounds dramatic. Tonight, imagine something much gentler. Picture a long mountain trail leading toward a peaceful summit. Along the path are many narrow passages. Every traveler begins the climb, yet only a few quietly continue beyond each winding turn. No single passage is impossible. They simply require patience, balance, and a little good fortune. Life, too, may follow many quiet steps before reaching the ability to look upward and wonder about the stars. Perhaps one of those steps is especially difficult. We simply do not yet know where it lies. There is another possibility that feels almost playful. Imagine visiting a beautiful nature reserve. The animals continue their peaceful lives. Visitors quietly observe from hidden paths. They take care not to disturb the delicate balance of the forest. Now imagine, just for a moment, that a very old civilization, somewhere in the galaxy, has adopted a similar kind of patience. Rather than announcing its presence, it quietly watches young civilizations as they slowly grow. Not to deceive them, not to control them, simply to allow each world to discover the universe in its own time. This gentle thought has become known as the zoo hypothesis. No evidence confirms that such a thing is happening, nor does any evidence completely rule it out. It remains one imaginative possibility among many. like a story softly whispered beside a campfire, interesting to consider, comfortable to leave unresolved. Perhaps the simplest explanation is also the quietest. Maybe the distances are simply too great. Even if intelligent civilizations are scattered throughout the Milky Way, they may be separated by thousands of light years. Messages would require thousands of years to travel in one direction. Replies would require thousands more. Conversations across the galaxy would unfold more slowly than mountains rise or continents drift. Imagine writing a letter today, knowing that your great-great-grandchildren's distant descendants might receive the reply. Would it still feel like a conversation, or would it become something gentler, a quiet exchange across the ages? Time, once again, becomes the universe's greatest silence. Perhaps civilizations do exist. Perhaps they are listening, just as we are. Perhaps they have heard nothing yet. Perhaps, somewhere beneath another quiet sky, another curious mind is asking exactly the same question at this very moment. The thought is oddly comforting. Across the galaxy, two listeners may sit beneath different stars, each wondering whether anyone else is quietly listening too. Neither knows about the other, yet both share the same peaceful curiosity. Science has not solved the Fermi paradox. In truth, it may never be completely solved, and perhaps that is perfectly acceptable. Not every beautiful question requires an immediate answer. Some questions remain valuable simply because they invite us to keep wondering, to keep observing, to keep listening. The silence itself becomes part of the story. As you drift once more through the calm darkness, the stars no longer seem lonely, they seem patient. The galaxies no longer feel empty. They feel spacious. The universe no longer feels silent because something is missing. It feels silent because its story unfolds on timescales so vast that even civilizations may become only brief whispers carried across an endless night. And somewhere beyond this quiet reflection waits one final journey, not toward another mysterious object, nor another distant galaxy, but toward the unimaginably distant future itself, where the stars slowly grow dim, the universe becomes quieter still, and time gently carries everything into its longest and most peaceful night. The silence of the stars remains with you. It is no longer an empty silence. It has become a peaceful companion, gently drifting beside you as you continue your journey. The galaxies still glow, the great spiral arms still slowly turn. Tiny worlds continue circling quiet suns. Yet somewhere deep within the flow of time, another chapter is already waiting. Not tomorrow, not in 1,000 years, not even in 1,000,000,000. But so unimaginably far ahead that language itself begins to feel wonderfully small. Imagine walking through an enormous library late in the evening. For countless generations, readers have quietly filled its halls. Soft lamps illuminate endless shelves. Pages gently turn. Footsteps echo through long corridors. Every room carries the quiet warmth of life and curiosity. Then, as the night grows deeper, the visitors gradually leave, one by one. No announcement is made. No one rushes toward the doors. Each lamp simply grows a little dimmer. Another room falls peacefully silent, then another. The library remains. It is simply becoming quieter, The universe may experience something much like this. Even today, stars continue to be born. Across distant galaxies, enormous clouds of gas slowly gather beneath gravity. Over millions of years, those clouds become warmer, denser, and brighter until new stars quietly awaken. Some will shine for billions of years, some much longer, some only for a comparatively brief moment before beginning another transformation. Yet the universe does not possess an endless supply of fresh material. Little by little, the great clouds of gas become smaller. Each new generation of stars gently uses some of the remaining fuel. Eventually, there will come a time when fewer and fewer new stars are born. Not because gravity has stopped working, not because nature has changed its mind, simply because the quiet ingredients needed for new stars have become increasingly rare. Imagine a gardener caring for a peaceful orchard. Every spring, young trees quietly appear. Year after year, the orchard grows. Then one season, fewer new saplings emerge. The older trees continue standing beneath the sky. Birds still rest among their branches. The garden remains beautiful. It simply becomes older. The galaxies may one day resemble that quiet orchard. The youngest stars will gradually become uncommon. Older stars will continue shining through unimaginably long evenings, patiently illuminating the darkness. Eventually, even those gentle lights begin reaching the final chapters of their own stories. Stars like our Sun do not end with great explosions. Instead, after billions of years, they quietly shed their outer layers into space. The glowing central remnant continues shining for an astonishing length of time. Astronomers call these peaceful objects white dwarfs. The name sounds almost delicate. In many ways, it is. A white dwarf no longer creates new energy deep within its heart. Instead, it slowly releases the warmth stored during its long life. Imagine removing a loaf of freshly baked bread from the oven. Long after baking has ended, gentle warmth continues drifting outward. Hour by hour, the bread slowly cools. A white dwarf behaves in a surprisingly similar way. It simply spends unimaginable ages becoming cooler, calmer, dimmer. According to our current understanding of the universe, something remarkable follows from this quiet cooling. If enough time passes, far more time than the universe has existed so far, a white dwarf may eventually become so cool that it no longer glows with visible light. Astronomers call this distant possibility a black dwarf. No one has ever seen one. The universe itself is still far too young. Not enough time has passed for even a single white dwarf to complete this extraordinary journey. So black dwarfs remain quiet predictions, patiently waiting in the unimaginably distant future. There is something almost poetic about that. Objects that no eyes have ever witnessed. Not because they are impossible, simply because time has not yet reached them. As the ages continue unfolding, galaxies slowly become darker. The brilliant blue stars, which once lived fast and brightly, have long since completed their stories. The quieter stars linger. Then they too begin to fade. The great spiral galaxies you visited near the beginning of your journey remain, but their light grows softer with every unimaginable age. their once busy neighborhoods become peaceful places, filled mostly with ancient stellar remnants quietly drifting through the darkness. The universe never seems hurried, even in its oldest years. It simply continues its patient rhythm. Astronomers sometimes describe this extraordinarily distant future using the phrase heat death. The words can sound surprisingly dramatic, yet the idea itself is gentle. It does not describe an explosion. It does not describe destruction. Instead, it describes a universe that has gradually become wonderfully quiet. Imagine a cup of warm tea resting beside an open window on a cool evening. Slowly, almost imperceptibly, the warmth spreads into the surrounding air. Eventually, the tea and the room reach the same gentle temperature. Nothing dramatic happens. Everything simply becomes balanced. In a similar way, the far future of the universe may become a place where energy has spread so evenly that very little continues to change. Not because the universe has disappeared, but because it has finally become deeply restful. Some people find this idea melancholy. Perhaps it does not need to be. After all, throughout your entire journey, the universe has shown you the same quiet lesson again and again. Stars become galaxies. Galaxies gather into great webs. Bright suns become gentle white dwarfs. Great black holes patiently wait. Quasars awaken and then quietly sleep once more. Nothing lasts forever, yet nothing is truly wasted. Everything changes. Everything transforms. Everything gently finds another way to continue. There is a remarkable peace in that rhythm. Perhaps the universe has never been telling a story about endings. Perhaps it has always been telling a story about patience, about allowing every chapter to unfold at exactly the pace it needs. As you drift through this unimaginably distant future, the remaining lights appear like tiny candles scattered across an endless night. Each one grows softer, each one more peaceful. The great cosmic library has become almost silent. Only a few gentle lamps remain glowing between the endless shelves. And somewhere, impossibly far behind you, hidden within all those forgotten ages, one small blue planet still quietly remembers what it once felt like to look upward and wonder. The universe has carried you farther than almost any journey the imagination can comfortably travel. You have wandered beyond familiar constellations. You have floated between neighboring galaxies. You have watched the delicate threads of the cosmic web quietly stretching across unimaginable distances. You have stood beside the oldest light ever observed. You have listened to the gentle heartbeat of pulsars. You have drifted among patient little red stars and peaceful worlds circling distant suns. You have rested near black holes that quietly shaped entire galaxies without ever raising their voices. You have listened for distant civilizations across the immense silence of the cosmos. And together, you have wandered so far into the future that even the stars themselves slowly faded into darkness. For a little while, you simply remain there, suspended between everything you have seen. There is nothing left to discover tonight, nothing left to solve, nothing left to hurry toward. You are safe. The universe asks nothing more of you now. It simply invites you to drift. Then, almost without noticing, you begin moving once more, not farther away, but gently back. Imagine following a quiet river downstream. Throughout an entire day, you pass forests, open fields, gentle hills, small wooden bridges. As evening arrives, you decide to turn around. Now every familiar place greets you once again. Nothing has changed, yet somehow everything feels different, because you have seen where the river eventually leads. Your journey through the universe feels much the same. The distant future slowly fades behind you. The quiet galaxies gradually become brighter once more. Ancient white dwarfs give way to younger stars. The great cosmic library slowly fills with light again. The long evening of the universe gently becomes morning. Time itself seems to flow backward through your imagination. Not because time truly moves that way, but because memory quietly gathers every chapter into one peaceful story. Soon, the brilliant quasars appear once more. Those ancient lighthouses that illuminated the young universe continue sending their patient beams across billions of years. Their light no longer feels impossibly distant. It feels familiar, like old friends waiting beside a quiet shore. The supermassive black holes resting inside distant galaxies remain hidden beneath glowing clouds of stars. You remember that they are not monsters, not endless mouths opening beneath the universe. They are simply another way gravity patiently shapes the cosmos, quiet, steady, almost shy. The galaxies themselves become easier to recognize. Graceful spiral arms slowly turn beneath the darkness. Elliptical galaxies quietly glow like smooth lanterns suspended in endless space. The cosmic web once again stretches before you like morning dew resting upon invisible threads. You remember how impossible it first seemed. Now it feels almost natural. You no longer see countless isolated galaxies. You see quiet neighborhoods, gentle rivers, a universe that prefers connection over loneliness. Farther still, the Virgo cluster slowly slips behind you. The local group quietly welcomes you home. Andromeda appears once again, patiently approaching across millions of years, not as an enemy, but as a future companion in a dance that unfolds too slowly for human eyes to witness. Nearby, the Milky Way gradually fills your view. Its graceful spiral arms wrap softly around you. Somewhere within one modest arm lies a perfectly ordinary yellow star. You have seen stars far larger, far brighter, far stranger. You have visited pulsars that pulse with astonishing precision, magnetars whose invisible magnetic fields quietly reshape the space around them. You have wandered among the oldest stars still shining in the galaxy. And yet, this ordinary star feels special, not because it is unusual, but because it is home. The sun has quietly accompanied every moment of your own story. It warmed the oceans before your first breath. It quietly greeted every morning you have ever known. Its light crossed the short distance to Earth every day without asking for recognition. Sometimes the most familiar things become the easiest to overlook. Tonight, perhaps, you notice them again. The blue planet slowly comes into view. Small, peaceful, almost delicate against the vast darkness surrounding it. From here, no borders divide its continents, no cities announce themselves, no voices rise into space. Only soft clouds drifting above blue oceans, gentle sunlight touching mountain ranges, a thin atmosphere quietly protecting every forest, every bird, every child asleep beneath tonight's sky. It is astonishing how small home appears after crossing the universe, and equally astonishing how important it feels. Everything you have learned, every galaxy, every ancient photon, every quiet mystery, has somehow led you back here. Not because Earth is the center of the universe. It is not, but because it is the center of your own experience. Every question you have ever asked about the stars began here. Every telescope ever built first looked upward from this little world. Every story about distant galaxies started with someone standing beneath an ordinary night sky, quietly wondering what rested beyond the darkness. Perhaps that is the universe's gentlest gift. It does not ask us to become enormous. It reminds us that even very small places can become windows into immeasurable beauty. You never needed to leave Earth in order to belong to the cosmos. You already did. Every atom in your body was quietly shaped by ancient stars. Every breath connects you to a planet orbiting a perfectly ordinary sun. Every heartbeat unfolds inside a galaxy that has patiently turned for billions of years. You have never been separate from the universe. You have always been one small part of its long, quiet story. And as your imagination gently settles back beneath the familiar stars of home, you realize that the night sky above your own world has never looked empty. It has always been quietly filled with old friends whose stories you now know a little better, waiting peacefully above you while the universe continues its endless, gentle turning. Your journey has become wonderfully quiet. The great galaxies no longer rush past. The distant quasars have settled into gentle memories. The invisible threads of the cosmic web stretch softly beyond your imagination, needing nothing more from you tonight. You have traveled farther than any spacecraft has ever gone, farther than any human being has ever wandered, not by moving your body, but by allowing your thoughts to drift slowly through space and time. And now, just as every peaceful journey eventually finds its way home, you find yourself resting beneath the same familiar sky where everything quietly began. Perhaps you are lying comfortably beneath a blanket. Perhaps there is the gentle sound of a fan nearby. Perhaps rain is softly touching a window somewhere, or perhaps the night is completely still. Whatever surrounds you now, it belongs to the same universe you have spent this evening exploring. Nothing separates your quiet room from the stars. Only distance, only time, only the gentle layers of air that wrap themselves around this small blue planet. Above them, the night patiently continues. The moon follows its ancient path. Satellites quietly glide overhead. Planets continue circling the sun with the same calm rhythm they have followed for billions of years. Far beyond them, the Milky Way slowly turns, carrying our solar system on its long journey around the center of the galaxy. The sun itself continues moving, just as it did before you began listening, and just as it will long after tonight has passed. Nothing has hurried, nothing has paused. The universe has simply continued being itself. There is something deeply comforting about that. Long before the first human looked upward with curiosity, the stars quietly shone. Long after every story told tonight has faded into memory, they will continue their patient work. Not because they are aware of us, not because they expect anything from us, simply because this is what stars have always done. They shine, they change, they gently pass their light onward. You have seen that even the brightest stars grow old. Even galaxies slowly change their shapes. Even black holes, those great quiet hearts of galaxies, spend most of their existence waiting rather than acting. The universe has never been rushing toward its future. It has always been unfolding with remarkable patience. Perhaps there is something we can quietly learn from that, not as a lesson, not as advice, only as an observation. The stars never hurry to become tomorrow's stars. The galaxies never rush toward their next orbit. The light leaving a distant quasar never worries about the billions of years that still lie ahead before reaching another world. Everything simply follows its gentle path, moment after moment, age after age. Perhaps tonight you can allow yourself the same kindness. There is nowhere else you need to be, nothing left to understand before sleep arrives, nothing left to solve before morning. You are safe. There is nothing to do, just listen and drift. As your thoughts grow quieter, imagine looking upward one final time. The familiar constellations rest above the horizon. Somewhere among those countless tiny points of light are stars that may have planets of their own. Some are younger than the sun. Others have quietly witnessed ages far older than Earth itself. Beyond them lie clouds of gas where future stars are slowly taking shape. Farther still, beyond what your eyes could ever see alone, other galaxies quietly shine across the darkness. Beyond those galaxies, the cosmic web continues weaving its delicate structure through the universe. And beyond even that, the oldest light still travels patiently across expanding space, carrying whispers from a universe only beginning its story. Everything you have imagined tonight continues at this very moment, not because you are thinking about it, because the universe never stopped. It quietly continues while people dream, while forests sleep beneath the wind, while oceans rise and fall with the moon, while children close their eyes, while distant stars gently burn through another peaceful night. There is something beautiful in knowing that you do not need to keep watch over it. The galaxies will continue turning without your help. Gravity will continue its patient work. Light will continue crossing the darkness. The quiet rhythm of the cosmos asks nothing from you. It simply carries on. You may rest now. You have wandered among ancient stars. You have crossed invisible rivers of galaxies. You have visited the brightest lights in the cosmos and the deepest silences between them. You have traveled into the unimaginably distant future and gently returned home again. Now, the journey belongs to memory. The universe can continue telling the rest of its story while you sleep. Perhaps tomorrow night, when you look upward once again, the stars will seem just a little more familiar, not because they have changed, but because you have quietly spent time among them. And so, our journey drifts quietly to its end. Whether you're still listening beneath the gentle glow of your screen, or already floating somewhere between dreams and distant stars, thank you for traveling here tonight, through silent galaxies, ancient particles, quiet black holes, patient stars, and the gentle laws that quietly hold the universe together. If this peaceful wandering brought you a little calm, you're warmly welcome to subscribe, or to share this journey with someone who could use a gentler night beneath the cosmos. For now, rest well. The stars will keep burning, the planets will keep turning, the galaxies will continue their slow and graceful dance. The oldest light in the universe will continue its patient journey across the darkness. And somewhere, far beyond everything we can see, the quiet universe will carry on softly around you while you sleep.